Hi everybody, it's Ranger John at Charles Towne Landing State Historic Site. And one of the topics that we interpret here at the park is navigation during the Age of Sail. But contrary to a popular myth, the medieval scholars who helped usher in this period of exploration were not flat earthers. In fact, they actually understood that the earth is round. How did they know this? Well, ancient Greek thinkers had proven it centuries before the advent of the Common Era. As early as the 4th century BC, the idea that the planet is a sphere was circulating among the intelligentsia of ancient Greece. Among the famous philosophers who subscribed to the round earth theory was Aristotle. Aristotle cited lunar eclipses as empirical evidence for the Earth's roundness, pointing out that the shadow on the moon is caused by the Earth moving between it and the sun, and further positing that the curved shape of the shadow demonstrates that the Earth is a globe. Another popular argument of the age involved ships and the horizon. When a ship sails toward you from beyond the horizon, its sails and masts are visible before its hull, while the opposite happens when one sails away from you. This would not happen if the Earth were flat or disc-shaped. But it was another Greek polymath named Eratosthenes who in the 3rd century BC finally offered definitive proof that the Earth is spherical in shape. Eratosthenes was the chief librarian at the famous repository of ancient knowledge in Alexandria, Egypt. There he learned of a travel account pertaining to the town of Syene, modern-day Aswan, Egypt, which lies near the Tropic of Cancer, several hundred miles up the Nile from Alexandria. This traveler noticed that at noon on the summer solstice, the columns in the town center did not cast shadows, and that the reflection of the sun could be seen in the center of the town's well. Eratosthenes reasoned that if the earth were flat, a column in Alexandria would also fail to cast a shadow at noon on the summer solstice. If it did cast one, as he expected, it would allow him to calculate the circumference of the spherical earth. On the next summer solstice, Eratosthenes conducted his experiment and found that his column did indeed cast a shadow, proving that the earth is round. Its angle measured 7.2 degrees, or 1/50th of a circle, which consists of 360 degrees. Thus, he concluded Syene is 7.2 degrees distant from Alexandria. Now, he needed to know the actual distance between the two towns, so he hired a professional distance walker who determined it to be 5,000 stadia. Scholars disagree over the exact length of the ancient unit of measure known as the stadion in Greek, or the stadium in Latin, but believe it was 500 or 600 feet. Armed with this data, Eratosthenes used algebra to calculate the circumference of the Earth. Solving for x, he concluded that it was 250,000 stadia. In modern terms, the Earth is actually 24,901 miles in circumference. Depending on the length of the stadion that he employed, Eratosthenes was either short by about 1,000 miles or inflated the figure by more than 3,000 miles. Either way, it was an impressive feat of science achieved with limited technology more than 2 millennia ago. Thanks for watching and for your continued support of South Carolina State Parks.